let's talk about how we defend against infection. There are two types of defenses against infection. One is innate or nonspecific. The other one is called adaptive or specific defenses. The innate defenses are the first and second lines of defense. They're general defenses that protect against many pathogens. The specific or adaptive defenses are our third line of defense, or immunity. These attack and build resistance to specific pathogens. So let's look at our innate or nonspecific defenses first. These are the 7 types of innate defenses, and I'll go over each one individually. So the first thing that we have is species resistance. This is part of our innate makeup. Some species just don't have the right environment or the right receptors for diseases. However, these are diseases that can be found in other species. So for example, there are diseases that we can get that we can't pass on to our dog. Right now, with COVID-19, they're trying to see what species might be able to get it. We think it's only in humans, but then there are studies coming back that certain animals have been able to get it. So the first line of defense you can have is that your species is just resistant. If your species is not resistant to a specific invader, you have your first line of defense. These are your mechanical barriers. These keep the invader out of the body to start with. They're like armor. These are your skin, your mucous membranes, your hair, your sweat, anything that's going to keep invaders from getting in your body in the first place. If invaders do get in your body, that's when we have to look at our second line of defense. The rest of our nonspecific or innate defenses are our second line of defense. So the first one are chemical barriers. Chemical barriers are going to destroy foreign invaders once they get inside our body. These are things like gastric juices in our stomach, different hormones or enzymes, proteins. These are different types of chemicals that are going to destroy invaders once they get in our body. We also have something called natural killer cells. These are kind of like trained assassins. They get a mission, they go after specific cells, especially viruses and cancerous tumors, and they kill them. These, unfortunately, can also become active with organ transplant. Your body, your natural killer cells, recognize the recipient organ as a foreign tissue, and so they attack it and try to kill it. This is not good, and so that's why you take immunosuppressants if you have an organ transplant, so that your body does not attack the new organ. Inflammation is another nonspecific defense. This is when you have a localized tissue response to injury or infection. You get swelling. It increases the permeability so that more fluid can come to the area. Fluid carries different things that need to be there for healing to occur, and you also have pus that forms. Phagocytosis is another nonspecific defense. It's going to remove and digest, so it eats up the foreign particles that are found within our lymph. And then we have fever. Fever creates an inhospitable environment to certain pathogens. So of course, fever can also be dangerous to our own body. We need to stay within homeostasis. However, our body at some times does need to care more about protecting us from foreign invaders than keeping our temperature where it needs to be. So our body will have a fever in order to try to kill off those pathogens. Additionally, phagocytes can attack more at higher temperatures. They like higher temperatures, and so the fever helps us fight off the infection. So once again, these are our 7 innate or nonspecific defenses. They just attack any foreign invaders. Then we have our specific or our adaptive defenses. Adaptive are things we've learned over time. These are our third line of defense, and they help us build up what's called immunity. Immunity is when we can fight and become resistant to specific pathogens. What happens is that lymphocytes, again, a type of white blood cell, and macrophages, another type of white blood cell, are going to recognize and then remember specific foreign molecules and fight them with specific responses. And so there are two different ways that we can really develop our adaptive defenses. One is that we come into contact with the disease itself. We fight it off. We remember it for later. If we encounter it again, we can fight it off again. The other is through vaccine. We'll talk more about vaccine later, but vaccines expose us to a disease without giving us the symptoms of the disease, so that if we were to encounter the real disease, we would be able to fight it off because we have the antibodies and our body knows what to do. It's training it ahead of time. There are two types of lymphocytes that we're going to talk about. The first one are T cells or T lymphocytes. These begin in red marrow. They go to the thymus, and that's where they differentiate. Again, this happens earlier on in life. You have a big thymus, and so they're going to differentiate there. They're going to become T cells. 70 to 80% of our lymphocytes are T cells, and they're also found in our lymphatic tissue. They participate in what's called a cellular immune response. These T cells will directly destroy the invading agents. So they go into hand-to-hand combat, if you will, with the actual invader. They're going to try to kill the invader themselves. This is different from B cells. B cells, or B lymphocytes, begin and differentiate in the red bone marrow. They make up the rest of the lymphocytes in our blood. They're also found in lymphatic tissue. They participate in what's called the humoral immune response. They indirectly destroy the invading antigens because they produce antibodies that destroy the antigens. So the B cells don't get their hands dirty like the T cells. The T cells directly fight. The B cells, on the other hand, are more like a coach. They produce good players, and those players are going to destroy the antigens. The B cells don't actually destroy the antigens themselves. They instead produce antibodies, and those antibodies destroy the antigens as part of this humoral immune response. So a quick recap for our lines of defense. A pathogen tries to get into our body. If we're not resistant to it as a species, our mechanical barriers will fight that off. I guess the mechanical barriers will fight it off even if we're resistant to it, but mechanical barriers are our first line of defense. They will protect us like armor from the invader ever getting in. If the pathogen enters the body, and again, our species is not immune to it, we have our second line of defenses. These are the things that try to kill these foreign invaders in general. These are things like hydrochloric acid in your stomach, our natural killer cells, which are like the assassins, inflammation, fever, and phagocytosis, just eating up and digesting these foreign invaders. We also have our third line of defense, which has the specific immune responses to specific invaders. Again, these are specific responses, whether in the cellular immune response, where they fight it directly, or the humoral immune response, where they produce antibodies that then fight it off.